to learn about this function that is new to you called a logarithmic function. Okay, and it's log for short. Okay, so log functions are logarithmic functions. And we're going to talk about the equivalent forms because logarithms are closely related to exponential functions. And we can write a log as an exponential function and vice versa. We're also going to do some graphing of the log functions and their inverses. And we're also going to do a real-world application today. So, like I said, a lot of times it's hard for people to say what is a logarithm. It is a function that relates a base and an exponent. Okay, and when you're doing the logarithm, it is the exponent to which that specified base is raised to obtain a certain value. So we're going to do lots of practice with that today. So you can write an exponential equation as a logarithmic equation and vice versa. So let's look and see how those are related. This is going to be similar to what you just did, except it's going to look a little bit backwards, okay? So what we did is we took b to the x equals y. That was our exponential form. And what we did is we rewrote it as log with a base of b. And then the y value was here, and it was equal to the exponent. Okay, so these two are interchangeable. In this form, your b is your base. Okay, the x is the exponent. Okay, and then the y is the result of the exponential expression. Okay, so when you evaluate the exponential expression, okay, in this form, that is your y. And you may have already noticed how to say this. You know, you've heard me say this. This is, the way that we say this is log base b of y equals x. Okay, so when we do something new, we want to make sure we're saying it correctly. So the way that you would say this is log base b of y equals x. Okay, and when you're writing this, the log and the y and the x are all on the same line. And we'll practice writing it out. Okay, so the way that you write that is going to be important. All right, so let's do an example. If we have log base 2 of 8 equal to 3, let's see if we can write that in exponential form. So what would you start with? Yeah, what's the base? Okay. And this should be a true statement, right? Okay, so this is going to be 2 to, what would the power be? What's the exponent? 3. And what's 2 to the third equal? 8. So one thing that helps me remember this is bay. I know, bay's not a thing anymore, is what second hour told me. Yeah, exactly. I have a shirt that says bay on it. Best aunt ever. So I still use bay. So if you can remember bay, this is your base, this is your answer, this is your exponent. Okay, so your base, okay, your answer is what it's equal to, and then you have the exponent here. There you go. Or you can just remember it like this, whichever you prefer. Okay? Alright, so for example 1, you're going to write each exponential equation in log form. Guess what? You've already done that today, so I'm very confident that you could do many of these without me. I am going to show you something different for B and C. Okay, so for A, it's 3 to the 5th equals 243. Doesn't that look like what we did on our warm-up page? Yeah, so this is going to be log base what? 3 of, yep, 243 equals 5. And I just want to be clear that this is not an exponent. This is the log and 243 are on the same place. It's just this is a subscript here. Okay? And that is your final answer. Okay, so you have your base. This is your exponent. Notice that the bay is only in log form. Okay, so you have your exponent, you have your base, and there you go. Okay, now for B, like I said, I'm going to show you something a little bit different with this. Have any of you noticed that there's a log button on your calculator? Yes, so you have log, this is log base 10 of 1 equals 0. Okay, the log on your calculator that you see is base 10. This is a special log. It's called the common log. So the way that you are going to write this, you guys don't have to get your calculators out right now. Okay, so if it's base 10, okay, you actually write it without the base because this is called the common log. Okay, so the common log has base 10. So if you see a log without a base, it's understood that the base is 10. Kind of like if you have x, right? It's understood that that's 1x. The log is understood that the base is 10. Okay, so using that knowledge, could you guys do part C? Okay, that's what I like to hear. I can try. Okay, so you have the log, and then your base is 10. And I'm fine if you want to do this in 2 steps or if you want to do it in 1 step. It's just if it's log base 10, you don't have to write it. So it's the log of 10,000 equals 4. Okay? Since since most of you do have your calculators out, you can verify this. Let's do the log. See the log? It's a log. It's right here. So we're going to do log of 10,000. And what should we get? 4. Yay, it's true. It's true. Uh-huh.
I have a question. If the base would be 20 and the log is usually given in tenths, would it be like 2 logs or something?
Nope, but there are ways to calculate it. I'm just not going to show you how to do that yet.
Okay.
So there's a change of base formula that we will get to though. Yes, that's a great question. There's also ways to change the base on your calculator, and I will eventually show you how to do that. Okay, and then for D, we have 6 to the negative 1 equals 1/6, so this would be log, and then the base for this one is going to be 6, and then it's of 1/6. Again, that is not an exponent. Okay, everything is on the same line except for the actual base, which is that subscript. Okay, and then Jack, will you tell me how to write part E, please?
It would just be log of A.
So log, tell me base A.
Yeah, base A.
Okay.
And then that just gets multiplied by C, right?
So not multiplied. So the log is something that it's of. So it's going to be log base A of C. So it's very similar to, do you guys remember in geometry when you had to do the trig functions, the sine, the cosine, and the tangent? You guys having nightmares right now? Okay, so remember when you use those functions, when you did like the sine, it always comes up like with the parenthesis. The log is the same way. Okay, so it's going to be of something, it won't be multiplied. And that's what the parentheses will mean in that case. Good. All right, so for example 2, now what we're going to do is we are going to write that in exponential form. Yay! Okay, so the log form, to help me with the log form, one thing I always remember is that it equals the exponent. because I know a couple of you said you wrote those out wrong when you were doing it the first time. I always make sure that it's equal to the exponent. So equals 5, equals 0, equals 4, -1, and b. So that's something that you can use to help you. And then with the exponential form, that's where I told you that's where your bay comes in. Okay. All right. So if we're writing this in the form, yeah, b, a, e. And again, when you're writing this in exponential form, it should be a true statement. Okay, so your base is 9, so it's 9 to the power of 1 equals 9. Is that true? Yes. They should always be true. Okay, okay. And then, Danny, can you tell me what b is going to be in exponential form?
2 to the power of 9.
Yeah?
Equals 512.
Great. 2 to the power of 9 equals 512. All right, and then Ashay, you want to tell me part C?
8 to the power of 2 equals 64.
Nice. All right, and then Emmy, you got part D for me?
4 to the -2 equals
Awesome. All right, and Sam, tell me E.
E to the power of 0.
Good. Now, even though that is a variable, anything to the 0 power equals 1. So we know that that's a true statement. Okay? Now, logs have special properties. Okay? There are some special properties that we can use to help us solve logs. Okay? Because we are going to be doing a lot of mental math today. So the log of base b, you would have log base b of b. Okay? Now, if you just had to figure out what that was, you'd be asking yourself, b to what power equals b? What would be your x in that case? 1. So this would equal 1. Okay? And that's because b to the first equals b. So this is a special property you could use. Okay? Something else that's special is the log of 1. So with this one, it doesn't matter what your base is. Let's say you have a log of base b. Okay, we'll just call it that, of 1. So again, when you're thinking about solving this, you would be asking yourself, b to what power equals 1? Yeah, 0. Okay, so this just equals 0. Okay, and again, that's because b to the 0 equals 1. And then the last one is the common log, and I already told you about that. That is a log with base 10. Okay, so then you would see it like this. The log of x, or sometimes you'll see it without the parentheses. Those are the same thing, okay? When you're doing it on your calculator, the parentheses automatically come up, because you have to take the log of something. The log does not exist unless it is of a value. All right, so let's do some examples of these. So for example, if you had the log base 2 of 2, okay, and you were told to evaluate that, you could just use this rule. If these are the same, the base, okay, and what you're taking the log of, what is that going to equal according to this rule? Yeah, it's just going to equal 1. So then 1 would be your final answer. Okay, so if you can recognize that, you could do it like that. You could also set it up exponentially, right? 2 to what power is 2? All right, and then for the next one, let's say you have log base 4 of 1. Again, the pattern that you want to recognize is, oh, look, it's of 1. The log is of 1. If the log is of 1, what does it have to equal? 0. Okay? Now again, these are special properties that you can recognize and use, or you can set it up as an exponential function and you would get there anyway. The last one though is something that we're going to write. So if you have log base 10 of 6, know that that's interchangeable with the log of 6. Now, the logs that we're going to be working with, bless you, are going to be, most of the logs we're doing today are going to be nice, which means you get nice whole numbers. But I do want you to know that sometimes you have a decimal, because if you think of this as an exponent, like 10 to the x equals 6, there's no nice number that would make that work, so sometimes your logs are going to be decimals. Okay? Can you think of a number that you could take log base 10 of that would turn out really nicely? 100. Do you know what the log of 100 would be? 2. Yeah, that's great. Get up. Yeah.
I have a question.
Yes.
If you want to type in a log into your calculator that has not base of 10, how do you do that? Because in the calculator, you said it's always 10.
Yes, so that's what I told you. I'm going to show you how to do that later. Yes, you won't need it for this section. Yeah. Yeah, as we get into like 4.4 and 4.5, we're going to be doing more with the calculator with logs. But today we are going to focus on a lot of the mental math part. Okay, so example 3, we are going to evaluate using mental math. Oh, you guys can do this. You're smart. Okay, so when you're doing mental math, okay, this is going to be just like what you did yesterday. Okay, so you can set these up as exponential equations, or you can also use the patterns that we just talked about. Okay, or you can use your log properties. So you can decide. We're always going to set these up as exponential functions. Okay. So the first one is log base 5 of 125. Okay, so the first thing I would have you do here is set up the exponential equation. Now, it's not equal to anything, so you can think of it as being equal to x. This would be 5 to what power equals 125. Okay? And then what would the answer to that be? 3. Good. Okay, so that's what you would have is 3. Okay? Alright, so based on that, why don't you do B? Log base 2 of 16. So the first thing I want you to do is I do want you to write that as an exponent, okay? Okay, so Dane, how would I write this in exponential form?
2 to the power of x.
Okay, good. So then did you guys solve that? What'd you get? 4. Great. All right, awesome. You feeling good about those? All right, let's try something looks a little bit different. So we're going to have the log of 0.01. Uh-oh. Okay, now what's the base? Good, okay, so the base is going to be 10. We know that because we can't see it, which means it's a common log. Okay, so when we write out the exponential form, it would be 10 to the x equals 0.01. All right, now decimals, doing those in our head, that's going to be difficult. So instead, let's think of it as a fraction. Do you guys know how to write 0.01 as a fraction? Yeah, what place is it in? The hundredths place, so this would be what? 1 over 100. Yep. If it was 0.1, it would be 1 over 10. This one is 1 over 100. Now, we know 10 to what power is 100? 2. But if it's 1 over 100, what's your x value? Yeah. Yep. So this x would be -2, and that would be your answer. Okay? All right, so I'll have you try B. How many of you are in chemistry or have taken chemistry? Oh, sweet. You're going to be great at this. That's unfortunate. Because we're good. All right, so this is the log of 0.00001. Okay, so let's set up our,
Step 40.
yeah, step 40. So let's set up our exponential form. You don't look like you like that one. Oh, sorry. No, you'll be good. You guys remember scientific notation? Okay. So this you can think of in a couple different ways, okay? So if you were thinking of it like we did last time, do you guys know what place that is? Hundred thousands, yeah, because you have the tens, the hundreds, the thousands, 10,000s, 100,000s. I'm also going to show you. A pattern here as well. Now, if you are familiar with scientific notation, which I think a lot of you are, you can think of this as 1 times 10 to a power equals 0.0001. Do you guys know how to find that now? If you have the 1, how many times do I have to move the decimal to get to 1? 5 times, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if you have to move it 5 places left. Okay, then your x value would be -5. Let's also notice what this pattern is here, right? So look, this was 0.01. To get to 1, how many places did I move it? 2 to the left, so it's -2. This one, I had to move it 5 places to the left, so it's -5. So see how you could just count it that way as well? It'd be a special pattern. You could use that. What's that? It's just moving the decimal. Okay, well let's try this using something similar. So log base 25 of 0.04. Log base 25 of 0.04. Okay, so I feel like you guys are doing a really good job of setting up the exponential form. Do you guys know what this fraction would be? 4 over 100, because it's in the hundreds place. And what does that reduce to? 1 over 25, right? 25 to what power is 25? 1, so because it's 1 over, it'll be -1. Yeah? Alright, and I'm feeling really confident that you can do these two without me, because they're very similar to what you did yesterday. Yes, you can. You guys are really smart. You're doing a really good job with this. Getting the hang of this? Yeah. Yeah. Mm-hmm. No. No. It's just so you can see this. Yeah. That's because you're 4 over 100, 1 over 25. Yeah. And it's 1 over 100, you might not know where it is. No. Because 5 to what power is 5? Yeah. So because it's 4 over 5, it's just 1 over 1. Yeah. Alright, so how did these two go? Pretty good? Feel better? With ones with fractions, I always say, okay, what's the relationship between the base and the denominator? If they're the same, and then it's 1 over, 5 to the first is 5, so 5 to the negative first, okay, is going to be your value for x. Okay, so this would equal negative 1. And then this, 4 to what power is 64? So 4 to the third is 64, so then it would just be negative. Does that help with the fraction ones? Thinking of it in terms of the denominator first? Okay. All right, then we will go to graphing. All right, so we are going to be doing some graphing of log functions.